intelligence maxing day 36. Currently on the train right now, headed to first day of work. So interested. Well, when I say work, really it's an internship, but I'm excited to see what's gonna happen. On the train towards Baltimore right now, and just left DC. So I think I have about an hour to go through some flashcards. Maybe try to finish up the books flashcards, although I don't know if I'll be able to. I also want to... I remember yesterday, we had talked about interest rate parity and forward contracts on interest rates. That was something that I wasn't super comfortable with. So I'm going to try to, maybe after this study session, go through a bit of a simple example of that. Let's go to it. Alright, so how is the India government structured post-1950? I think it's similar to the US, if I remember. So India is a federal republic. So federal meaning that there's a federal or sovereign government and it controls the entire nation or governs the entire nation. And then a republic in the sense that it's controlled by the people. The government is controlled by the people through elected officials. So you're electing officials, or the people are electing officials, and they're the ones that are influencing policy to hopefully help their constituents. Now, I think there's something called a union group or a union territory. I think that's unique to India. I think these might be areas on the border of India, maybe towards Pakistan and China. Maybe even Nepal there might be some disputed borders around there. And territories. Okay, so union territories, which are regions governed by the federal government. I do hard, because I forgot that they were governed by the federal government. With individual states. Yeah, that's important. Oh man, can't get it. Okay, but that was hard. So how can one estimate? Alright. So this is the interest rate parity, the super pristine credit company minus some credit spread, or I think you could do a lookup on credit rating for certain currencies and then add that to the return or yield on a government bond. Yeah, to form an estimate of the default spread on government bonds. Subtract the default spread. To get the risk rate, so we want to subtract the default spread and expect a return. Yeah. So, statistically measure risk added by an asset to the market portfolio. I remember doing this, and I feel like it has something to do with covariance. So, covariance is kind of a statistical measure of how two variables move in relation to each other. And if you have positive covariance, they tend to move in the same direction. If you have negative covariance, they tend to move in opposite directions. And if you have a really small covariance or correlation, then there's really no pattern in the direction that they move. So yeah, covariance is probably the risk. And then if they have high covariance, then you're probably gonna increase the risk of your portfolio So the way I'm thinking about this is if the two are right? Or even this, if the covariance is greater than 1, then trying to think, yeah. Covariance is greater than 1. Then you're possibly adding more risk, but if you standardize it so it's a correlation, then it just becomes 1. I guess if they're perfectly correlated, so if their correlation is 1, I wonder if you add your asset to the market portfolio, would that increase the standard deviation? I don't think so, right? Would it increase the standard deviation of your portfolio? I guess maybe it could, because if you're adding Okay, now that I'm thinking about it, if you look at the math behind the variance, right? So you're adding let's try to break this down. So in the 2 asset scenario, right? I'll call this variance of R is equal to W1, so this is the weights times the so W bar of W1 times R1 plus bar Right, so the variance, I believe it's this. So the variance of W1, so R is equal to W1 R1 plus W2 R2. So the returns of our asset is, oh shoot. No, I just deleted it. Okay. Alright, so I think I might have just deleted it by accident. Let's try to define it again. So the returns on our 2 asset portfolio is just equal to W2 R2, right? And then if we want to find the variance of R, we could just distribute this, the variance, but we also have to add a correlation term. So I believe, or we'll call this the covariance term, not necessarily the correlation term. So this will be W1, R1, and then W2, R2. Right? So if they're completely independent, then this just becomes 0. I want to say, how do we get from... Yeah, why does this show up? I'm trying to think about kind of like the statistical underpinning for this, or the mathematical proof. I'm trying to think, so... Let's think about what variance actually is. So variance is of R is equal to the sum, call this X, sum of X minus X. We'll call this, at a high level, if we're trying to find the variance of some random variable, we're just trying to find the sum of the random variable, the actual observation, minus the mean, or sometimes with a sample is the sample mean, and then we just square it. I think the other way of doing this is the expectation of X. So there's two different things here. I guess with this then, what are we replacing X with? This becomes R, and this is also becoming R. Alright, so what is R though, right? So if we replace this then,
Hey, we got the same color on again today.
R becomes...
Probably think we alike. Oh my gosh, it's funny.
Alright, so I think if we replace this, R then becomes... Let's see, so we have W1, R1, plus W2, R2, and then we subtract, so subtract W1, R1. Okay, we'll call this the expectation.